All right, we're going to go ahead and get started. Welcome to today's webinar, Mini Kubeflow, Kubeflow on your laptop. I'm Vangelis Koukis, co-founder and CTO at Arrikto. I'd like to thank everyone who's joining us today. A few housekeeping items before we get started. During the webinar, you're not able to talk as an attendee. There's a QA box at the bottom of your screen. Please feel free to drop your questions in there, and we'll get to as many as we can at the end. This session is being recorded and will be sent out afterwards along with a link to the presentation. So let's kick off today's presentation. Why Kubeflow? Kubeflow is an end-to-end solution for running machine learning workloads on Kubernetes. Workloads run containerized in containers managed by Kubernetes. It's a platform that allows you to explore experiments and run state-of-the-art AI. Its purpose is to help new users become proficient in the platform as quickly as possible, so it's easy to onboard new users. It has an outstanding community, a very vibrant community, and lots of industry support. What is Mini Kubeflow? We're going to do a live demo of how you install Mini Kubeflow. Mini Kubeflow is our packaging, Arrikto's packaging of Kubeflow in an all-in-one way. So you can run it on your laptop in as easy a way as possible. So let me switch to a secondary desktop. And 1 second. Okay. Apologies for the mix-up. So, installing Mini Kubeflow is essentially two commands. A, creating a directory on my local system, switching into this directory, initializing a Vagrant machine, more about this later on, and then starting this machine. What this does is it starts a virtual machine on your laptop. All of Kubeflow runs on Kubernetes inside this virtual machine. We'll run a small deployment script when the machine is up, and we will be up and running within 10 minutes. So Mini Kubeflow is a way to get up and running with a full Kubeflow deployment of the latest version within 10 minutes, essentially. And that's what we're going to be demoing. So Vagrant, which is a system for managing virtual machines that we are using with Mini Kubeflow, provisions the machine at this point. The machine is up, and Vagrant instructs us to visit this URL to continue. So I'm using my browser, visiting this URL, and this connects to the virtual machine. So this is a small provisioning tool that comes with Mini Kubeflow that you are supposed to run the very first time you install it. We started from scratch, and each time you restart Mini Kubeflow's machine. So each time you essentially reboot your laptop. And what it does is it makes sure everything is up and running so you can start using Kubeflow. At this point, nothing is installed, so Kubeflow is down. Rock, our data management software, more about it later on, is down, and you don't have any credentials to log into Mini Kubeflow. So let's start. Okay, accept the end user license agreement. So what the script does at this point is deploy a series of software packages that allow you to run Kubernetes locally and then deploy Kubeflow on top of this Kubernetes instance. So we provision Docker, an orchestration engine for containers. We provision a number of Docker images, a number of software packages that we bring locally, so you can run this in an air-gapped environment. Okay. A number of images is being deployed. And then at this point, we provision MiniKube. MiniKube is a local installation of Kubernetes. So this will take around 2 to 3 minutes. So let's switch back to the presentation and talk more about MiniKubeflow. So what is MiniKubeflow? It's Kubeflow on your laptop or on some sort of on-prem infrastructure that you may have, a bigger ML rig maybe. It's an all-in-one installation of Kubeflow meant to run on a single node. It features the latest Kubeflow version, 0.5. As you can see, it's quite easy to spin up your own environment. You don't have to deal with Kubeflow's installers directly. And it's a combination of MiniKube, the Kubeflow software itself, and Arrikto's, our ROC platform for managing data. More about ROC later on. So what exactly is Kubeflow? This is a figure from the TFX paper by Google. And it describes the TFX platform that Google uses internally to do machine learning. So the front end of the platform, Google has open sourced most of the components mentioned at this paper. So data analysis, data transformation, data validation, the training component, evaluation, serving, all of these things are TFX libraries. Okay, and then Kubeflow packages these things in a way that allows them to run containerized on Kubernetes. Kubeflow gives you an integrated front end to manage your jobs and work with the system. So it gives you a UI to manage notebooks, for example, that we have contributed, by the way. Kubernetes is the shared framework to run these containers. So Kubeflow manages containers on top of Kubernetes. And then for pipeline storage and garbage collection and data access, we integrate our software with MiniKubeflow and Kubeflow. More on our software later on. Let's switch back to deployment. So deployment is progressing. MiniKube was installed. We're now deploying our software. We're deploying an operator for ROC. We wait for the operator to get up and running. The operator is up and running. The script does this automatically. We deploy quite a few more software components. We're using etcd, which is a distributed key value store, to manage internal ROC state. We deploy a database, and this is all happening automatically. And then at this point, the script will wait for ROC to get up and running, so it can then deploy Kubeflow on top of ROC. So we expect when this job has been completed successfully, and these 3 pods are up and running, that this button here will become green, will be up, and we'll be able to connect to ROC. And then the script will continue with deploying Kubeflow on top of ROC. So switching back to the presentation, what exactly is ROC? Why are we deploying ROC along with Kubeflow as part of MiniKubeflow? ROC is a way to version, package, and share your data. So ROC, our software, runs underneath Kubeflow. Arrikto is a core Kubeflow contributor, and we are contributing code in Kubeflow to make its components data aware. Data aware as in able to work with persistent volumes on Kubernetes, PVCs. Then our software integrates via an interface called CSI with the rest of Kubernetes. So Kubeflow uses PVCs managed by us. This data is stored directly on whatever storage you provide at each location. We assume there's 3 distinct locations in this ML workflow. So there's one location for experimentation, maybe a different location for training, the Google Cloud, so you can have lots of GPUs to train, and then a different location where you run production, where you run inference. So our software runs on all 3 locations and allows you to version your data locally, package it in a way that's transportable, and then share this data, transfer it from location to location as data snapshots, as versioned data snapshots in a peer-to-peer network. So the data you produce at the experimentation phase can then be picked up by the training phase, and the trained models can then be moved to production where you run inference. So what's new in the latest version of MiniKubeflow? We have upgraded it to work with latest Kubeflow 0.5. It features a new notebook manager UI that we contributed that runs directly over Kubernetes and manages your notebooks as pods on Kubernetes. It supports Kubeflow Pipelines, which you can run locally. So you can be using the same APIs, the Kubeflow Pipelines APIs, on your laptop to do local development of pipelines before you then move them to a bigger location, maybe to the cloud, so you can run them at scale. It integrates notebooks with pipelines using our software, which means you can be managing data inside a notebook. You can be pre-processing data and manipulating data before you seed a Kubeflow pipeline with this data. So you start a pipeline from data that you have manipulated inside a notebook, and essentially allows you to run an end-to-end flow, starting from a notebook, importing your data, manipulating it, and then seeding a pipeline from it. More on this in next Friday's webinar, where we demo a complete ML pipeline with Kubeflow pipelines, starting from a notebook with MiniKubeflow. So back to our deployment. Rock is up and running. The script is now provisioned in Kubeflow. So what it does is it creates resources needed by Kubeflow. It declares software components, the software components that Kubeflow comprises. And we're waiting for a rather large number of pods, around 30, to get up and running on our local deployment. So when all of these pods are up and running, Kubeflow will be up, and then we'll be able to use the platform. So another major component of MiniKubeflow is the landing page that we are using right now. You can use it to directly interact with the provisioning script without having to visit the command line to do that. It guides you through deploying the basic components, and then gives you an easy way to access both Kubeflow and Rock. Why did we start MiniKF, MiniKubeflow? There was no easy way to get Kubeflow up and running on your local laptop. And we have seen that lots of exploration, lots of experimentation starts at the data scientist's laptop. So we make it easy for the data scientist to spin up a Kubeflow platform, so they can start working using the exact same APIs that they will then use to run at scale. We don't want them to be developing using different APIs and a different environment compared to what they will encounter when they want to run at scale. So they can develop their pipelines, they can run their notebooks, they can use Kubeflow libraries such as Fairing locally. They can run end-to-end locally on MiniKubeflow, and when they have verified that everything works, They can switch to a different location, run on the cloud at scale, move to inference in production. And because we run Kubeflow at every location, including laptops, they can write the exact same code and have it run on Kubernetes in a uniform way. So essentially, Mini Kubeflow is local Kubeflow. It gives you a unified user experience, exactly the same environments, same Kubernetes APIs, same Kubernetes custom resources that you can submit to your Kubernetes cluster, same way to run your notebooks, run your pipelines, run fairing. A uniform way of managing ML workflows, both locally and on the cloud. Back to our deployment, provisioning is complete. The services are up and running. Our credentials are here. So what is this local experience, right? Connect to Kubeflow. Okay, Kubeflow is up and running. This is Kubeflow's dashboard running locally on Mini Kubeflow. You can access all of Kubeflow's components from this pane on the left-hand side. This is the notebook component. No notebook servers are running right now. We can start a new server. We can specify the characteristics of our new server. This is integrated with Rock in Mini Kubeflow. And then we can move to pipelines. This is pipelines. A few sample pipelines are already preloaded. This is Kubeflow running on your laptop. And then, because this is Mini Kubeflow, you can also use Rock. This is Rock, running locally again. You can log in using the provided credentials. This is it. So Kubeflow gives you a way to start experimenting. Rock runs on the side, so you can manage your data locally. We released the first version of Mini Kubeflow around March, early March. Since then, it's been downloading by short of 2,000 people, and its adoption seems to be progressing nicely. We are trying to release every new Kubeflow version within a few days or weeks, packaged as Mini Kubeflow. What you just saw, installing Mini Kubeflow is essentially two commands. You need Vagrant and VirtualBox installed as prerequisites, and then you run a single Vagrant command to initialize our Mini Kubeflow box. Box is a way to run prepackaged software with Vagrant, and then you start the Mini Kubeflow VM and go through the provisioning script as I just demoed. You need a pretty hefty machine with around 12 gigabytes of RAM because Kubeflow does have quite a lot of components and is quite resource hungry. We recommend that you run with 2 CPUs at least, around 50 gigabytes of free disk space. And then because this is virtualized, you can run it on Linux, on Mac OS, on Windows, and expect the same user experience across all operating systems. Vagrant and VirtualBox are the two prerequisites. And then what we plan to do in future Mini Kubeflow versions is enable support for GPUs. So if your laptop or your ML rig where you have deployed Mini Kubeflow on supports, has GPUs, then you can train on these GPUs. Support hybrid and multi-cloud pipelines, and we will be using Rock functionality for this, so you can start running a pipeline on one location and then transfer pipeline state to another location so you can continue running the pipeline somewhere else, essentially run a hybrid split pipeline across on-prem and a cloud location. End of the month, Kubeflow 0.6 will be released. So we will be packaging the latest 0.6 version as a new Mini Kubeflow version. We will be contributing a volume manager UI to Kubeflow, which will help with managing files data in general with Kubeflow. So it will give you a very easy way to essentially import and export your data in and out of notebooks, so you can then see your pipelines. We have a hash mini Kubeflow channel on the Kubeflow Slack. Please join the channel so you can report issues, give us feedback, ask for new features. This presentation will be made available. We also have a user survey we'd like you to complete. Next Friday, we will be using MiniKubeflow. Hopefully you have installed it by then, to run an end-to-end Kubeflow pipeline on MiniKubeflow. So we'll start from a notebook and run the taxi cab Kubeflow example locally on-prem on MiniKubeflow. Start from a notebook, create the pipeline, compile the pipeline, run it on Kubeflow pipelines, and explore the final results. So please try out MiniKubeflow. Installation instructions are here and as part of the Kubeflow documentation. There's a nice blog post you may want to read, a video of the end-to-end tutorial that we will be presenting next Friday, and we're looking forward to your feedback. This was it. If there are questions, let's see. So I will be reading some of the questions. Do we need to have VirtualBox installed? Yes. Current MiniKubeflow works with VirtualBox. VirtualBox is not a hard prerequisite. Kubernetes does not need VirtualBox. We base current MiniKubeflow versions on VirtualBox to provide for a very easy, uniform experience. But we'd like to have your feedback on this. If you need, if you feel it should run on other platforms, if you have a specialized request, please join the Kubeflow Slack, join #MiniKubeflow, and let us know what you think. Do I mean 2 cores or 2 CPUs? Well, yeah, 2 cores would be okay. Something that can run 2 things in parallel. It does have to be 2 physical processor packages. A dual core CPU, for example, is okay. We create a new VirtualBox machine that runs with 2 virtual CPUs. So these 2 virtual CPUs would run on the dual core processor. Does MiniKubeflow support fairing? Yes, we support every single Kubeflow component. So you can use standard Kubeflow notebook images. Fairing is included as part of these images. You can actually deploy MiniKubeflow right now and try out fairing components, fairing examples. Fairing works with Kubernetes. We deploy Kubernetes as part of MiniKubeflow, so it will work. So another question from the chat is, does the provisioning step happen every time we start the Vagrant VM, or is it only done once? That's a nice question. So you need to go through the provisioning script every single time you start the VM, but because we maintain state inside the VM, next time you run the provisioning script, it's not going to take 10 minutes, it's going to take 2 minutes. Why? Because it essentially waits until all of Kubeflow's components are up and running. So what we're doing is, the very first time the provisioning script starts, it won't find anything deployed. So you'll wait for 10 minutes, as we did now. And when everything is deployed, it will allow you to log in. So yeah, if you shut down the machine and you restart it, the components will already have been deployed and they will start to get up and running. Kubernetes will be running them, starting them. So you have to go through the provisioning script just to make sure that everything is up and running. The provisioning script will make sure everything is started and say, okay, everything is started, now you can log in again. So it's kind of an easy way to know when everything is up and running. Do we need to have VirtualBox installed? Yes, Vagrant is a prerequisite, VirtualBox is a prerequisite, and then you can Vagrant in. So can we have a demo of fairing on MiniKubeflow, I think is the question. All examples are related to GCP. So that's a good question. Because a big part of the Kubeflow community is Google, lots of examples have been deployed on GCP. So in creating mini Kubeflow, we essentially ensure that Kubeflow runs nicely and provides a very good user experience on an on-prem platform. So next Friday, we have a tutorial, a webinar that demos an end-to-end Kubeflow Pipelines example on mini Kubeflow, hence on-prem. So in making this work end-to-end, we made minor fixes to the examples and we ensured they ran on-prem with no GCP dependency. So can we have a demo fairing? Yes, thanks for the feedback. Next Friday's webinar is going to be a Kubeflow Pipelines webinar. We will also plan for a fairing webinar. Please join the Mini Kubeflow channel on Slack and we can talk more about it. Any other questions? Can we make Mini Kubeflow work without Vagrant? Yes, but the question would be why? What would we have to gain? Would you want it to run on bare metal directly on your Linux machine? Would we then be able to run and provide the same user experience on Windows and on macOS? We don't plan to abandon Vagrant soon because this allows Mini Kubeflow to have a very uniform user experience. But we do plan to explore other Mini Kubeflow versions that could run in other environments. Please also join the Mini Kubeflow channel. Let's talk more about your requirements. Why would you want to see Mini Kubeflow run without any Vagrant dependency? I think this is it. That's all of our questions. Thank you for joining us. In the coming days, we'll send you a recording. Yes, so it's fun because the questions are exactly what I want to talk about. We'll send you a recording of this webinar along with the slides that I presented. We look forward to seeing you at the next week's webinar. We will demonstrate an end-to-end machine learning workflow with Kubeflow pipelines on-prem with Mini Kubeflow. Thank you. Have a great day.